Hello there, it's Cliff here with the Hallmark Impact Tolerant Touch Probe Operator's Manual. I thought rather than just adding extra clips to the original Operator's Manual video, starting to get a bit unwieldy and long-winded, I'd just do a part 2. So this video will add to the original video. As I get requests for more information, I'll put it into part 2 and post it online as a non-public video with a private link. One question I had, for example, recently was I haven't explained very well how to measure the pre-travel. So when you've plugged your probe in and you want to know what the pre-travel is, one thing I didn't mention was that just set it on its slowest jog speed and just jog in slowly until it contacts. And the moment it contacts, you need to be a little bit sensitive about using your shuttle controller or whatever, but just move in very slowly, and the moment it contacts, it'll stop. And if you've got a light pressure finger indicator on the other side, you can read off how much was the pre-travel in that orientation, and then you can turn it around a few degrees, back off, and just come in again and just contact, jog in until it contacts, and then you'll get the pre-travel in that particular position. Just clarifying that point. Cheers. If you're having any kind of electrical problems, here's a couple of little tips. So your DIN plug, if you get a multimeter and connect it via alligator clips to the 2 key pins, that's one in from each end, so that pin and that pin, or one either side of the central pin, that pin and that pin, connect it up to your digital multimeter. If you want to get really keen, you can solder up a little socket like this. So that's connected up now. Okay, then we'll put our multimeter onto impedance and circuit testing mode. And if you have it on the audible, it'll be a quick and easy way to check that it's switching in all of the directions. So I'm going forward, backward, left and right. Okay, so that's all good, but if it's not connecting in one direction, you may, when you've disassembled it, or may have introduced a little bit of fluff or dirt, or just a little bit of thick grease that's got in there somehow. What you can do is loosen all the cap screws, just enough so that the heads are out of their countersinks, like that. So you've got this looseness, push it in and then just rattle it within the clearance of the cap screws, and that may well cause the spring-loaded pogo pins to ride over a little piece of grease or fluff that's got in there, and you can hear it audibly come right if there's a little connection problem. I mean, really ideally you should fully dismantle it and wash it out with kerosene and blow it off with compressed air, but if you just want a quick fix to get it going for a job, you could try that. Just loosen it off, give it a little rattle, and tighten up your cap screws and check that it's going in all directions, because it's possible something could be just held apart with a little bit of fluff or a little bit of unwanted thick grease that's got in there. That method I just described of loosening those screws and rattling the end cap by the clearance, I would recommend that you always do that on reassembly. That don't just pop the screws in and tighten them up, but give it a little rattle first, just to make sure that the different contacts, the pogos and the contacts, have all found their way correctly home. Okay, well, let's go into the electrical circuit a little bit more deeply. If you want to test the probe, normally you just plug it into your machine and move the probe tip and watch in the status to see that it's tripping okay. But let's say you want to test it off the machine as part of a troubleshooting process. Let's just look at the circuit. It's a very simple circuit. There are 6 or 3 pairs of switches, or contacts if you like, and the circuit goes through those switches or contacts and returns to the CNC machine electrics and control software. So when one of those 6 contacts or 3 pairs of contacts is broken, or the switch is open, then it shows as a trip in the control software. And the normal state when the tip of the probe is not touching the work, the spring returns the switches to the normal state of circuit closed. So there's continuity of electrical current flowing through the probe. Now when the probe tip touches the work, the circuit is open. And here we're showing these 3 pairs of switches in the open state. Now it may only be half of one of those switches, one of those 6 contacts broken, but here I'm just showing all 3 open. So now the circuit is open and the control software is tripped and showing an open circuit. Okay, so the fault is most likely to be, and just as a note, it's this probe, the Hallmark probe, has proven to be very reliable in in-house testing and all beta testing so far. We haven't had any faults, but sooner or later there will be a problem, and it's most likely to be in the circuit closed situation. Here in its normal state, all the 6 contacts are closed and there's continuity of current flow. It's most likely to be a fault in that circuit due to one of the contacts being at fault. In other words, a poor connection on one of the 6 contacts, and that could be due to a piece of dirt or dust or fluff or hair between the contacts. Is probably the most likely thing that would happen, and in that case you'd refer to the section in the operator's manual on how to clean out the inside of the probe and the contacts and reinstall the ITTP fluid or gel. Okay, well let's just go now to how you would check off the machine. So if you connect some alligator clips to the 2 terminals, to the 2 pins in the 5-pin plug, that's the one either side of center, and put that through, connect that up with your multimeter, put it on to the sound mode, and one of them's just come off. Okay, I've got a proper little socket here normally, but okay, that's connected up now. So that's registering the complete circuit, the closed circuit, and when we break it, you can hear in each direction the circuit's been broken, and if it was connected to the machine, the software would be triggered or tripped. So that's how you can check the circuit off the machine. So just going over that again, you can check it in all directions by listening to the little continuity beep. Now if there's a fault and that's working fine, but in one direction you release the probe, say, and there's no beep, then clearly there's a problem in one of the pairs of contacts. And that is confirming that there's something wrong with one of the pairs of contacts. Either a little piece of dust has got in there, possibly longer term there could be oxidization or arcing or something on the contacts, and then you'd go to the section in the manual where you redress the points. I mean, that's yet to happen, but one day it may well happen. So you'd polish the points with the 2000 grit paper and wash it off with kerosene and reapply the fluid. Now, in addition to those most likely faults, there's also a possibility that a probe has or will develop a very rare situation where there's a short in the actual probe itself, so that when the probe should be open, the circuit should be open, it remains closed due to a short. Or it could be that there's a break in the electrical circuit, a dry solder joint or a faulty connection somewhere else in the circuit, and that would mean that when the circuit should be closed, it remains open. And I'll just go through a couple of ways you can check that. Okay, so to test for a short, we've got our little alligator clips set up here on the DIN plug, like that. And we've got the circuit beeper going. Now if we remove one of those, a bit awkward, the camera in front of me, sorry I'm fumbling a bit here. Okay, now we don't want to have a connection through the body of the probe. And there's nothing there, but if it was beeping, then that would be a sign that there's a connectivity of circuit between the main live wire running through the probe and the body of the probe. And that would be a sure sign of a short, and that would give issues with the function of the probe. So in the area of a short or an incorrect connection within the probe, we're just looking inside the end cap now. The 6 ball contacts should not be electrically connected to each other. So the end cap is anodized, and that's an insulated surface, and the balls should not be in contact with each other. And you could check that if you ever have a short problem. Again, you've got your circuit tester here, and you'd contact one ball and check the other balls. Contact the next ball and check the other balls. Just to check that it's never happened, but again, one day it might happen. There could be a connectivity between one ball and another, and again, that would mess up with the function of the probe. Now, if there's a fault in the circuit due to it being open when it should be closed, in other words, the probe tip is not touching the work, the spring returns the contacts to their normal state of circuit closed, but in actual fact there is no current running through the probe, there is no closed circuit, then it could be due to a break in the circuit within the body of the probe, a dry solder joint or a poor connection of a pogo contacting on the balls and so on. And if you look at the section in part 2, it'll show you the electrical circuit components, how they fit together, the type of things that could be wrong and could be checked to find where that fault is and correct that fault. Okay, let's go through the electrical wiring. So you might want to change the cable, the main cable, if for example you want to fit a longer cable or a shorter cable. So the plug is a 5-pin DIN plug, and it has connections to the 2 pins either side of center. So not the extreme pins and not the central pins, but the 2 pins either side of center. It can be a plus or minus connection. So it's just a 2-core cable connected through to that DIN plug. That's nice and simple. One little screw holding it in, and down the other end, I'll go into that in some more detail in a moment. While I've got the camera on this point, there's two what we call pogo links, and they're spring-loaded link circuits. They are, okay, let's get a pointer out. That's the pogo pins there and there, and there's a central piece of copper, single core copper wire joining them together. This is the stage of making them in case you need to replace them. So that's them soldered together. So you've got the two pogo spring-loaded contact plunger pins, gold-plated, and a central copper core. The central copper core is 39 millimeters long, and it's about 0.8 of a millimeter diameter wire, or 1 millimeter diameter wire, but in that range. And then once that's made up, you shrink on some very small heat shrink tubing, a piece in the middle covering the central portion of 1.5 to 0.8 heat shrink tubing. That's that very small heat shrink tubing. And then the same heat shrink tubing at each end. From memory, each piece is 24 millimeters long at each end, with a little piece shrunk over the top again, just to build up the diameter right at the end of about 8 millimeters long. I've done that in a different color just to contrast it, and that gives it your insulated diameter right down that end. Then it's bent into this shape so that it can slip into the body of the probe. Okay, so it's quite a fragile little component, and if it was removed a little bit carelessly, then you could crack the solder joint or peel loose some of the heat shrink insulation, and either of those two situations could cause a short or a broken circuit. So just be aware of that if you're troubleshooting an issue there. Okay, so on the other end of the main cable, this is just cut off to start with there. Take the main outer insulation back a distance of 30 millimeters. So you end up with this situation, and then take the small diameter insulation back a distance of about 30 millimeters there, and about 22 millimeters off the end, so you've got about 8 millimeters here. Just checking you can see this okay. Alright, you've reduced it down from 30 to 22 with 8 millimeters of insulation. Just solder the first few millimeters, twist the copper and solder the first few millimeters there, and then in the end of the pogo pin you'll see there's a little cavity which you fill with solder, and solder the two together like that. Just check that it's not raised in diameter. It should be slim and of even or smaller diameter through there, and not out of line on an angle. If you're using a large diameter bit of cable, you might want to remove some of it. In this case I'm taking about 1/3 of it out and cutting it off there, so that I end up with a main bulk of cable of of just over a millimeter, about 1.1 diameter. There's more than enough capacity there, because you want to keep the profile of all of this quite slim in order to assemble it. So once we've got to that stage, we solder on the little pogo pin, and we have this. Then we heat shrink on some tubing, larger diameter tubing. Where is it? This section here. which is 2.5 to 1.25 heat shrink tubing, and we heat shrink down over this length here, just a little head of the pogo pin down over the insulation of the main cable. So then we have that type of construction. I know this is all pretty obvious if you study it, but some of these points do make it go a bit smoother and lessen the chances of you getting it wrong. So now we need to put the gland parts on to the cable. So we've got this construction here, and we're going to thread on the gland nut there. We're going to put on the little rubber shroud or sleeve there, and then we're going to put on the gland threaded sleeve there. It goes right out the way. Now, the way this is assembled is that you get the body and thread that through there and feed it right up. So you'll need to be careful not to buy or use a cable that's too big to assemble through the body. So the diameter of this cable is quite big and beefy. This is about a 1/4 inch, 6.25 roughly cable, and that just makes the whole thing more durable and solid, but I've used that size. Now once that's through like that, you bend the two ends at right angles, a length of about 41 millimeters back from the end, 41 millimeters, bend a right angle bend. I'll just do that now and then come back to you. Hold on a minute. So busy talking I forgot to put the insulation on the end. So you've got the small diameter heat shrink tubing, 1.5 to 0.8, 24 millimeters long, that goes on the end of the pogos. Let me just do that now. A bit awkward working around the camera, but you can see the pogo needs to just protrude beyond the length of the heat shrink tubing. You can actually rotate it there. And then over the top of that, I'm using a different colour to contrast, still having the contacts protruding. Come at it from both sides so that you shrink the heat shrink tubing on evenly, and you can just roll it between your fingers just to make sure that there's no lumps or bumps on it, like that. Okay, so now it's looking like this, and you have the pogo ends with a bend at about 41 millimeters from the end to a sharp bend, which you probably use pliers, very light pressure so you don't crimp through the insulation tubing. You might use a bit of hot air just to set it on that sharp corner, and then we just feed it back in, entering the pogos into the adjacent holes there and pulling the main cable down and just gently feeding it in. Don't use any force. It has to enter without any force. And if it's not going in smoothly, it's because something is snagged, and you just need to be a bit careful to ease it in. And then finally, I'll probably need to concentrate just getting everything in line, pulling it down gently, and I'll get back to you in a sec. Okay, we've got the wires right in now. The pogos are standing out like that. Check that they spring in and out freely. If they stick in, there's something wrong. What can happen, where am I? With this assembly, if there's a lump of solder on the side, or it's lumpy, or you have a problem with your heat shrink tubing folding back, or something's off center, it'll cause the assembly to be biased, and it won't spring forward freely. So you need to pull it apart and check everything out. You might need to replace your heat shrink tubing, or replace the cable, or replace the solder joint until you get it operating smoothly. If everything is correct and it's still a little bit stiff and not always springing forward, but everything's in good alignment, you can put a little trace of the ITTP, impact tolerant touch probe, ITTP gel on it, a little bit of the fluid on it. Okay, so got that far. Now we're going to screw in the gland fitting. We're going to push in the little rubber protector. Finally screw on the gland nut and tighten it up. Just a note here, I've started leaving out the little plastic sleeve. That's designed to really grip on the cable, and it certainly does that well. The problem is that you tend to over tighten it, and the plastic little sleeve bites too deeply into the cable, and I think on balance it's better to have that out and just to have the rubber sleeve in there. And finally, you put the two link pins in. Now these are quite fragile. Make sure that the heat shrink tubing is neatly and evenly shrunk on. There's no loose ends or doubled over section, and at the ends where it's double thickness are not swollen or lumpy, that you haven't wrenched them in or out and cracked the solder joint, so you then have a dry solder joint and so on. So check those out. You may need to rebuild them if they're at all damaged. Then you can slip those in. Again, don't use any force. It's a bit awkward doing this with the camera in front of me, but you get the general idea. So they slip in like that. And again, check that the little pogos are protruding, and they should spring in and out evenly. If they don't spring in and out evenly, there's something wrong. There's a bias, a misalignment, a lump of solder or something, and it needs to be corrected. Alright, so that's the assembly. Don't do it in a hurry, it's pretty critical work. It's important that there is no broken solder joints. I'll stop fiddling with it while I'm talking. That there's no broken solder joints, that the insulation is intact, and most importantly, the little pogo pins are all free to spring in and out to make contact with the balls. So that's it all together now. So just reiterating, it's important that all the pogo pins move up and down freely, and that the little gold contacts on the end are exposed, that there's no insulation over them. And if that isn't operating properly, you could well have problems with the connectivity of the circuit when you put it all together. Okay guys, that wraps up this current version of the part 2 of the operator's user manual for now anyway. Catch you later.